Hello everybody. We are going to continue with a new journey at the International gvSIG conference, and I'm going to speak about version control system on gvSIG desktop, advanced cartography editing in open source software. First of all, I'm going to share desktop. And I'm going to start the presentation. Well, first of all, I want to highlight the title, open source software, because there wasn't anything about advanced cartography editing in version control system in open source software, and now we have developed this tool in gvSIG desktop. We have two different situations. First one is the multi-user editing, and the second one is the versioning. For the multi-user editing situation, we have two different options when we work with shape files or other formats based on files, and when we work with databases. For the first case, we can have several problems. For example, when only one user can simultaneously modify a file. So the file only can be modified by one user. Two different users can edit this file, but in their computers, in their local copy. So there is a problem because we don't know which is the correct shapefile. When we work with databases, the problem is that they need high-speed connections. And about users editing, there are different cases, and the problems are when two users are editing the different features at the same time and the same features at the same time. So what changes remains, we don't know. It's very difficult to manage these options. About versioning, we have two options too when we work with shape files or other similar formats, and when we work with databases. When we work with shape files, we usually organize our data in folders with different versions. We usually name the files with 1, 2, 3, etc. So it's not easy to recover a version of a geometry, an old version of a geometry. It's very difficult to maintain these options. Now with databases, we can create backups for each version, and it's easy to implement, but it's not easy to recover an old version. They also manage high data volume. And also using specific tools of the database manager, we need administrators specialized in the database manager and tools dependent on this database manager. So how can we solve these problems for multi-user editing and versioning? Are there any solutions implemented in other areas? For this problem, we can use version control systems. Currently, there are several version control systems. For example, SVN, that is a centralized VCS. Git and its web version, GitHub, that is a decentralized VCS, Mercurial, etc. But can we use one of them for our cartography? Are they useful for us? They are usually oriented to text files. For example, they are very useful for documentation, for source code, etc. But they are inefficient with binary data, and the cartography is in this type of format, not in text. Another problem is that decentralized systems replicate all the information, so it requires large volumes of to replicate large volumes of data. And another problem is that they are not integrated into a desktop GIS. So they require external tools that are different than the tools that we use for editing. So if we can use any of them, the options that we have we have another option. So now we have VCS GIS for gvSIG desktop. It's a new tool available for gvSIG desktop. It's a centralized version control system. It's designed to manage cartography, map data, and the most important thing is that it's integrated into a desktop GIS. I want to summarize what a version control system is. It allows to edit vector layers and recover the situation of the geometries in a concrete time. It stores not only the information, but also the modifications that the users have made on the geometries. The version control system for GIS it's focused on the geographic information, and it uses a central database, mainly Oracle or PostGIS, but we can use H2 database for our local geometries, our local data. In this case, this version control system, each user is working on their local copy, and they upload the changes to their repository. Here we can see a common problem. There are two users. They read the same file. The first one is editing the file in their local copy, and the second one is editing at the same time. The first one uploads the changes to the repository, and they replace the version firstly, and the second user overwrites the other version. So there's a problem because the geometries of the changes of the first upload of the first user are lost. We decided we had two options, two possible solutions. The first one was rejected. It was the block option. With this option, the repository was locked, and only one user can edit the information at the same time. Only one user, and there were problems when sometimes users lock the files and forget to unlock them. So the other users couldn't work during that time. They could be several hours without working because the file was locked. And the adopted solution was the copy modification merge model. With this model, the user works on their local copy, and they upload the changes when they finish. And if there is any conflict, they decide which change they want to keep. So with the version control system for GIS available in gvSIG desktop, we can edit disconnected from the server. We have concurrent editing. We also can resolve the conflicts. For example, we have commit, update, merge, and revert options when we use the cartography, the editing tools. We also have versioning, so we can access to the previous version of the data to recover a geometry in a concrete date. We also have another tool that is the export, to export the cartography, to see the cartography, how the cartography was in a specific date. So it's very useful. So we can see, for example, how the pavement was in a municipality, how the pavement of the signs were in a concrete date. And the most important thing is that it's integrated with a desktop GIS, in this case, gvSIG desktop. It's integrated with this case, we have the vector editing tools available directly in gvSIG desktop. It also allows to include topological reviews. So it's very useful because, for example, if we are uploading geometries that overlap with the geometry that is available in the repository, we can get a message with this problem. So we can include topological reviews. We also use data models for alphanumeric editing. It's very useful because we have different tables that are connected to our data. So, for example, we can use these tables for the values or of the combos that we have for the different fields, for example. Or another example, we also have advanced search tools that, for example, if we have a shapefile with the vertical signs, we can have an external table with the models of the vertical signs. So there are hundreds of them. So it's very useful, the search tools, because we can filter by type of sign. For example, we want to find the endangered signs, so we can apply filters and we can get the vertical sign that we want. So it's very useful. And we have forms for data entry. Here you can see an example of a screenshot of the new version control system GIS tool with all the tools that are available. And here you can see, after editing, we can upload the changes. We can see all the changes that we commit to the repository. I'm going to summarize the typical workflow with the version control system GIS. After the first thing is to update our working copy. We download the information of the repository and we edit our local copy first. So we are editing our local copy only. We change the geometries, the alphanumerical information, we create new geometries, and finally we submit the changes to the repository. So after that, the changes are uploaded, and after that, if there is another user that has edited the same information, we can, if there is any conflict, we can decide if we want to keep our changes or the changes made by the other user. So it's more or less the typical workflow for the version control system. Here you can see some screenshots, but I'm going to show you a short video about how it works. Here you can see, for example, we have to initialize the working copy first. So we have to select the repository. In this case, I'm connecting to an H2 database in local, but we can connect to a remote repository. For example, it's very useful in a municipality. They can have PostGIS or Oracle with the information, and instead of connecting by a local database, we can connect by a remote repository, by URL. So it's another case. And we also can, we also have to select the folder and the name of the working copy in our computer. So we will edit the working copy in the local working copy. So now we are going to select the name of the working copy and the folder in our computer, and after that we will edit only the working copy. So we are selecting the folder and the name. For example, the name will be related to the repository that we have selected. We have the repository number 1, so the name of the file, it's very useful to name repository 1 working copy 1, for example. After that, we have the working copy, and now we have to connect to the data model. In this case, we have to select the working copy, and we can get the data models available at the repository. For example, in a municipality, we can have different data models. For example, for sign, for parks and gardens, for inventories. So we can have different data models. The data models include all the tables that we can see here. For example, all the tables that are related to this data model. In this case, I have the urban sign, and the different tables are vertical signs, vertical sign images, horizontal signs, etc. And all the tables with the values of the different fields. Now we have a new tab in the Add Layer window that is Version Control System GIS. With this option, we can add the layers from the working copy. So now we can select, for example, the pavements for the base cartography, and it hasn't been downloaded first because it is a lot of information, so we can download the information of the layer, and after that we will select the pavement layer. So we are adding the layers to our view from the repository to our working copy. And we have selected the urban sign. So after that, we add the layers. We also can get these windows that are the scale, the visualization scale, because probably we will have some information that we don't want to see in different zooms, for example. So we will select the scales of the visualization, and after that we are going to zoom to layer. We have two groups of layers. The first one is the urban sign, and the second one is the base cartography with the pavements. Here you can see the vertical signs. The images of these vertical signs are in a different table. So after connecting to the data model, we can get the images of the vertical signs, for example, as you can see here. They are related to a bracket also, and we can get different types of brackets that are in another table of our data model. So now we are start editing, and we are going to create new geometries, to move geometries. In this case, we are copying as an arrow, and we are going to move it to another location, and we are going to copy this crosswalk to the other side of the cross. So we are going to copy it, and we have new geometries, an arrow and 4 rectangles of the crosswalk. So we are editing our working copy. It's very important. very important, we are editing only our working copy, and after that we will upload the changes to the repository. We can also edit the alphanumeric information, and here we can see it's a customized form with the different combos. The values of the combos are in different tables of the data model. We can have date fields, and we can have also we can customize it with the mandatory fields. So they are in red color, and if there is any field that is not field, we will get a message with a cross, a red cross, that we have to fill the field. So we have changed the color of the arrow. You can see here that we have changed the color of the arrow. And after that, we have a new tool to check the geometries that we have edited. If there is one of the lines in red color, is that there is a problem, because there was a mandatory field, at least one mandatory field, without filling. So now we have finished editing, and now we are going to see the changes. So here we can select our working copy, and we have the changes that we have made. We select the table. We have a line 2 of this layer, and several geometries at the horizontal signals. We can zoom to the to the different geometries that we have modified or added, and we are uploading the changes to the repository. So if there is another user that is working in another computer, the other user has to download the changes from the repositories to update the changes. So now we have updated the information at the repository from our working copy, our local working copy. And now I will show you another case about conflicts between two users. So it has finished, and now we have two different users. We are working in the same gvSIG application, but it shows that it was different users, first user and the second user. So it's the same case. The second user has to download the changes that the other user have made. We can see these geometries that are not uploaded, that are not updated in the user number 2. So the user number 2 has to update the information from the repository. Here we can see the second user can't upload the changes that he has made, because he has to update the changes from the repository first. So now we will see the changes at the repository. And he will update their local copy from here. Now we can see the two geometries that the other user had changed. And now the second user can upload the geometry. Okay, first, before uploading changes, the user has to check if there is any change at the repository. And now we can see the first user has updated the information too. And now we are going to see a second case when two users are editing the same feature, the same geometry. The first user has changed the geometry to the other side, to the right side, and the second user has has moved the geometry to this position. So there is a conflict. The same geometry with two different changes by the first user and the second user. So the first user has uploaded the changes, and now the second user has to decide if he keeps the change of the first user or his change. So in this case, he has decided to keep his change. So after that, we can see that the geometry, here we can see the other change. So now he has to decide which change he wants to keep. And he has this option. So he can do the other option to keep the change of the other user or his change. And after that, we can see that the change that will remain is this one. Okay, I'm going to continue to finish the presentation. The version control system for GIS is available from gvSIG 2.6 version. It's a version that it's in development, but there are several builds that you can test, and you can check this new tool. Okay, so the final version will be available soon. And that's not just a version control system. That's not just a desktop GIS, but it combines both things in one application. The desktop GIS, gvSIG desktop, with the version control system inside the application. It allows us to maintain and prepare the cartographic information, and we can publish this information later in our, for example, in our geo portals. So it's integrated with the products of the gvSIG suite, gvSIG desktop, gvSIG online, and gvSIG maps. And thank you very much. I'm going to see if there is any question at the chat. And if there isn't any question, you can ask us at info@gvsig.com if you have any question about this tool, and we can reply to this mail. So there isn't any question, so I'm going to finish this presentation here, and I invite you to continue with the next presentation today and tomorrow. Thank you very much, and see you.